Casting is the most versatile process for producing metal parts. There is no limit to size and shape of the parts that can be produced by this method. This process is not only cost effective but also provides high strength and rigidity to the cast components. Intricate parts which are difficult to produce by the conventional machining methods can be easily produced by casting in foundry. Due to these facts, cast parts are gaining importance day by day. Components made in foundry are widely used in automobile industry, farm sector, and machine tools. Various methods of producing cast components are sand casting, die casting, investment casting, centrifugal casting, and shell molding. In this program, we will discuss only the sand casting process. In sand casting, the various steps are pattern making, sand mixing, mold making, core making, metal melting and pouring, fettling and inspection. Pattern is a replica of the desired shape of the components, which when embedded in sand produces a cavity called mold. The size of the pattern is kept more than the size of the finished components to allow for shrinkage and machining allowances. The patterns are made from wood, aluminium, cast iron, steel, brass, and magnesium, etc. Pattern may be solid or split type. Patterns are generally made on precision machines. Quality of cast component will mainly depend upon the quality of the sand used for making molds and cores. Molding sand must have some specific properties such as refractoriness, porosity, plasticity, adhesiveness, cohesiveness, and collapsibility. To have these properties, binders and additives are added to the silica sand. The common binders are molasses, bentonite, dextrine, linseed oil, and fire clay. The common additives are coal dust, sawdust, fuel oil, and cereals. Silica sand, along with additives, binders, and water, are thoroughly mixed in a mixer. mixed sand is then tested for the desired properties before making molds and cores. Mold is a cavity created in a compact sand mass with the help of a pattern. This mold, when filled with molten metal, gives a component of desired size and shape. Let us now see the mold making process in detail. First, the pattern is put on flat board or plate. The parting compound is dusted on the pattern. It helps in easy removal of pattern from mold. Then, a mold box called flask is placed over the pattern. A layer of facing sand is put on the pattern. The remaining flask is then filled with backing sand. The operation we see here is called ramming. It helps in filling and packing the sand uniformly in all directions to have a compact sand mass. The extra sand is removed with a stripper bar. Vent holes are made to provide passages for the escape of air and gases at the time of metal pouring. Lastly, the mold box along with pattern is turned upside down. In a single piece pattern, the other half of mold is made over the first mold, as is the case here. These are the runner and sprue rod. They provide passage in the mold for the flow of molten metal to the mold cavity. The same process is repeated for making the other half. Lastly, the pattern is removed carefully from the mold. The complete mold generally consists of two halves. The lower half is called drag. The upper half is called cope. In case the pattern is split type, then the two halves of the mold are made separately. Here we have molds ready for pouring of metal. Molds can also be made by machines, where machines are used for packing and ramming the sand in the mold box. Cores are used for producing cavities in the casting. Cores are made of specially prepared sand. They are made in core boxes. Cores are baked before use. Baked cores are put into the molds at the appropriate places to provide the desired cavity or recess. The metal from which the component is to be made is melted in a furnace. The furnace may be coal-fired, oil-fired, or electric furnace. Here we have a coal-fired cupola furnace for melting the metal. Before pouring, the prepared molds are cleaned with compressed air. The cope is then placed over the drag and clamped. The molten metal is carried to the mold in the crucible and poured slowly into the mold through the sprue hole. The metal enters the cavity via the runner and gates. To ensure proper filling of the mold, pouring should continue till the metal comes out through the riser. After allowing the metal to cool and solidify in cavity, the molds are broken. The extra metal like runner, gates and risers are hammered off from the main casting. The burnt pieces of core and mold sand remaining in the casting are also removed. Then the cast components are cleaned by shot blasting. This also relieves the internal stresses in the cast components. Finally, the castings are inspected for size and shape. So, we can rightly say that foundry is an important manufacturing process. The intricate components which cannot be manufactured by conventional machining can easily be produced in a foundry.